Okay, so here what we're going to do is I'm going to do an example which demonstrates how we can use trigonometry to find the lengths of unknown sides of a right triangle. So we're going to be given two angles in a right triangle. Although if we're given two, then we really know them all because we know that the sum of the angles of a triangle add up to 180 degrees. And we're assuming, as you can see here, we have the length of an unknown side. We have the length of an unknown side. We have one side whose length we know, excuse me. And there are two sides that are unknown. Their lengths are unknown, but we're going to find those using right triangle trig. All right, so let's do that. So what we're going to do first is we're going to find the length of side A. Okay? So what do we have here? We have an angle, right? We have the 90-degree angle. We know this angle here, 37 degrees. Although technically we really could get this angle up here if we wanted to. But for now, let's just stick with the 37 degrees. So we have 37 degrees. We know that the opposite side is 40. We want the adjacent side. So we have the opposite side. We have the adjacent side. So if we go to SOHCAHTOA, just fill it up here, like so. So we have the opposite and we want the adjacent. That's over here. So which trig function do we use? Tangent. And that's what we're going to use here to get A. So we have tangent. We know that tangent of 37 degrees, tangent of the angle is opposite, which is 40, all divided by adjacent, A. But again, we want to figure out what A is down here. Okay? We want to figure out what the A is down here. How are we going to do that? Let's solve for it algebraically. So solving for it, again, what we can do is this. We can multiply both sides by A. Does that help us? Well, these are going to cancel. And what we end up with is tangent of 37 degrees times A is 40. Okay, we're not quite there because, again, we want A. So what do we do next? Well, let's divide. Let's divide by tangent of 37 degrees, tangent of 37 degrees, okay? Does that help us? Well, yeah, because these are going to cancel. We're going to be left with A equals 40 over the tangent of 37 degrees. All right, so now what we have to do, though, is we have to figure out what tangent of 37 degrees is. Well, that's where our calculator comes into play. So make sure also in your calculator, you're in degree mode. If you're in radian mode and you type tangent of, if you type in 37, then press tangent, what's going to happen is the calculator will think you want tangent of 37 radians. And that's not what we want. We want tangent of 37 degrees. So make sure your calculator's in the right mode. So here, we're going to get tangent of 37. And since I'm rounding, in the above notes, if you saw, that I'm going to round to 4 decimal places. So what I'm going to use before the end in intermediate calculations is more than 4 decimal places. So it turns out that tangent of 37 degrees, actually I think it might be better if I do this. There we go. That's about equal to 0.7535554. Okay? So I'm using 6 decimal places. So I rounded to 6. It turns out if you did this in your calculator, after 4 you would have a 0, so which is why we get this. So what is this quotient equal to? Let's see. We end up with about 58. So here I'm going to round to 4 decimal places. Let me just make that a little bit nicer. get 58 point, here we go, 0, 8, 1, 8, approximately. So, no, excuse me, not 58, 53. Sorry, read the calculator wrong. 53.0818. Okay, so that is the length of A. Okay, so now we found A. Okay, I didn't write it in, but we did that already. We're not going to use A, though, to find C. So now what we're going to do then is find C. We're not going to use A. I mean, theoretically, you could use A because you could just use Pythagorean's theorem. However, we're dealing with, we want to learn trigonometry here. So let's avoid Pythagorean's theorem and use trigonometry to find C. Okay, so what do? Well, so again, we have our angle here, which is, as before, 37 degrees. We have the opposite side, which is 40, and we want the hypotenuse. Opposite, hypotenuse. Which trig function do we use? Well, let's go to SOHCAHTOA. Okay, so opposite, hypotenuse. Here it is. We're going to use sine. That's what the S is over there. Sine. Move this down a bit. Okay, so again, let's use sine. So we have the sine of 37 degrees is equal to opposite, which is 40, all divided by C. Okay, so now, just like before when finding A, what we want to do is solve for C. So it's really actually a similar calculation, right? From here, we're going to multiply both sides by C. Okay, how does that help us? Well, these are going to cancel. Below it, we're going to have sine of 37 degrees times C. That's going to equal 40. Okay, so again, we're not quite there, but we're getting there, because now we can just divide by sine of 37 degrees. We want C to be all alone, like so. These cancel, so we get C. Let me write it over here so we have room. Is 40 over the sine of 37 degrees. Now we have to calculate sine of 37 degrees. How do we do that? Well, that's again where the calculator comes into play. Well, it turns out you're going to get sine of 37 degrees is about 0.601815. So again, I use 6 decimal places because basically I want to use more than 4 because I want to round to 4 at the very end. So before the end, we use 5 or more decimal places. Okay, so now we're going to calculate that. And we get so I just did it in the calculator. We get about 66 point, oh no, excuse me, what am I doing? 66, let me just fix this. 66.4656. That's our answer for C. So that's what the length of C is, approximately.